All right, there we go. Okay, so my name is Mark. This is my third video in this series here on things A&P related, aircraft electrical and avionics. I've been away for a bit. It's been several weeks since I've done a video. I was sick with I think a sinus infection, and then I got COVID, so finally up and running here. Also gonna double check my microphone. It looks like I got sound coming through here. Okay. Sweet, and then I'll set this to present. All right, so this week I've got aircraft electrical connectors for A&Ps, junction blocks to cannon plugs. So this will be over a couple of different things. I know that I've gone a bit long on the other presentations, so we'll see how long this one takes. I think I was at about an hour on the other two, but we'll see how it goes. So anyway, just a quick intro here. We're going to go over the basics of electrical connectors, types of connectors, splices, terminals, contacts, and then for anyone that is kind of new to the channel, wanted to kick things off by mentioning that I have a free A&P quick start guide, which will kind of walk you through the process of getting your A&P. So it's a free downloadable PDF guide for people who are completely new to the A&P process and have no idea where to start. For military people who are transitioning over to the civilian side, and anyone who's working currently as an aircraft maintenance tech but doesn't have their A&P. This guide will just walk you through the process of what you can do to get your A&P certificate from the FAA. So the link is in the description down below right now, and that's at markhjoy.com/quickstart. So check it out, free download. Hope it's helpful for you. Just a gift for stopping by and checking out today's presentation. Okay, so first section here, we wanted to get into aircraft electrical connectors. And I'm just going to go through kind of a handful. The main theme here is that there are lots of different types of aircraft connectors and terminals and splices and pins and contacts and all of that stuff. So there are so many different kinds. I don't have like part numbers memorized necessarily, but this is just going to kind of go through the bulk of what you'll see on an aircraft. And just know that when it boils down to it, you're probably going to have to look up some tech data with the component that you're working with to make sure that you're getting the correct information about any of the specifics. But this will just kind of go through the basics of what you're going to come up against. So I'll kind of bounce around here. I have some pictures up and running too throughout here. So going to double check the chat here one more time and see if anyone has said anything. It looks like no. Okay. And basically, if anyone has any questions and is watching along, just save your questions to the end, and I'll go through them at the end here. So I think that will just be easiest. So, okay, back over to the content here. So. All right, so first connector type that I want to talk about were circular connectors, also known as cannon plugs. And we'll just jump over to the next slide here, and we'll take a look at what those look like. So circular connectors, pretty much just what it sounds like. These are a bunch of different types of circular connectors, come in a lot of different shapes and sizes, different size contacts, and used for a lot of different applications. But these are what circular connectors are going to look like. I'm getting way ahead of myself here. Rectangular connectors are also a different style that you'll see. So just as it sounds, they're rectangular connectors. Here's a little snapshot of what rectangular connectors look like. So You can see there's sort of like a rectangular connector with with rectangular inserts in the inside of the connector itself here, but lots of different flavors. These are rectangular connectors. D-sub miniature, these are also known as D-sub, are going to be connectors that look like a D shape as you look at them from the front or back. And if you've ever connected a a computer connector, hooked up a computer, this is pretty similar to what you're going to see with like an old DVI connector, but yeah, you can see there's sort of like, if you were to turn this on its side, it has like a D shape to it. Lots of different sizes for these D-sub connectors, but this is a D-sub connector. And then we have coax. And these are a handful of different types of coax connectors. But also, maybe if you've ever hooked up a cable TV or something like that, this probably looks familiar. So these are coaxial connectors that go on the ends of coaxial type cables. And then Molex, those are sort of simple plastic type connectors that are used for less robust applications. So usually used for like lights that go throughout the cabin, and yeah, just very simple applications that are not really very complicated and sort of like low power. If they're using power, and that's what it's going to be more likely than not, is power and ground. But you can see there are these little plastic connectors. So yeah, pretty simple. Nothing too complex about the contacts either. And then for junctions and terminal modules, those are going to be for common connections where you're trying to maybe connect two signals together, and maybe where you don't necessarily want to splice them, or have like an inline splice in a wire bundle. So it's just sort of like a common connection area for different wires that need to be on the same circuit. And they're basically like modules that you can insert the different wires in after you terminate them, put a contact in them, and they go into the module itself. So it provides continuity between several wires. So it's just like a common junction point for the wires. And other styles of junctions or terminal modules, there can be diodes or resistors or other electrical components within them that do different functions. And then some of them can be used specifically for grounding, and there can also be modules that are used for relay applications. And so just give a shot of what those are. Okay, and you can see here, this one at the bottom right, you can see there's a little line that separates the two circuits. So like on the left side, you would have all of these wires that are pinned into this section of the connector would be continuous to each other. And then on the right side, on the other side of the line, those would be continuous to each other, but they would not be continuous between the two sides. So yeah, that's one example of a terminal or junction module. And this one up in the top right here is just a 1-to-1, so it's more or less just a splice, but you can pin and depin this little connector. And then on the bottom left here, this type of terminal would be secured to bare airframe, so it would be used for grounding circuits. So like you would have a group of wires that are just being grounded in this little module here. And then in the center, you can have like a little rail that the modules themselves fit into, just so that they can be secured in the aircraft. All right, so those are the different types of terminals and connectors, just sort of at a glance here. And then sort of some miscellaneous notes that I wanted to mention here were also that connectors can be high density, which basically just means that there is a large amount of pins that are within the connector insert. And so I've got an example of high density here. So for the D sub, this one here has, you can see 50 position, and then normally it would probably be like half of that. So there are some cases where they squeeze a bunch more pins in than is really like comfortable. And then connectors can either be mounted or just sort of unsecured. So if they're mounted, they're probably going to be in a rack or mounted to a bulkhead or a panel. And if they're in a rack, they can be floating, which helps with connection of an LRU to the connector. So on the left here is an example of a rack-mounted connector. And so within the rack here, you would install a line replaceable unit. So like the black box or computer, whatever you want to call it, would slide into this rack here. And in the back of the computer, there's a connector on the back of the computer that mates up with the connector that's mounted in the rack. And this connector basically floats in the rack, just so there's some amount of tolerance, so that you can easily install the computer into the rack and make that connection. And then you've got some knurled knobs here up in the front, which are used to secure the computer into the rack itself. So that's a rack-mounted connector. And then one other thing that I wanted to mention here too was that you can also have feed-throughs, which are basically just like a circular area that fills in a hole through an airframe, through a bulkhead or a firewall, and then you pass wires through the feed-through and then seal it up with like a Pro Seal. So just wanted to mention that it's not a connector, so they're compared to like a bulkhead or panel-mounted connector where there are wires that are needed to pass through. It's just going to be a hole, basically a hole in the airframe that gets filled in with Pro Seal so that the area can be pressurized, but you can still feed wires through it. So just wanted to mention that as a note here. All right, and then key components of connectors. You're going to have a back shell, and I'll point out what these are in my pictures following here. But you'll have a back shell, which is basically a cover that goes over the connector and the insert to protect the wires at the termination area. And the insert module is the actual part of the connector that houses the contacts inside of the connector, and there's going to be some sort of locking mechanism or even a weatherized sort of what do I want to call it? Weatherized material like a silicone or a rubber of some sort if it's a pressurized connector. And then obviously the contacts, like I said, lock into the connector insert module itself, and the contacts can either be a pin or a socket. and that can also include quadrax or coax connectors and lots of other different types of contacts that can go into connectors themselves. And then on most connectors, there's also going to be some sort of strain relief, which is a component of the connector that you can secure the wiring to, so that if the cable bends near the connector, it's not going to sort of pull the pins out or pull the wiring out of the pin or contact rather. So it's basically just there to secure the wiring to the connector and prevent any strain at the back of the connector. And then it's also very common to have some sort of key or polarization of a connector, so that they can mate with each other properly, and especially that can help prevent connecting the wrong connector to the wrong mate. So it's very common to see keying, and like if you look at the face of a connector, like you can see different keyways on the face of the connector. And then there's also going to be some sort of locking or securing mechanism on the connectors themselves. And there can be like a visual indicator that shows that it's the connector is locked, but there can be like a ratcheting mechanism that's on the connector, or like a screw and a nut, or a bayonet type of connection that secures the two connectors together. Okay. So first to talk about back shells. So in this example here with the D subs, this blue sort of plastic piece is what's called the back shell, and over here in this exploded view, you can see this is the back shell sort of disassembled. The insert module is going to be this piece on the inside here. You can see where the different holes are, where the contacts insert into the insert module. And then these are just sort of looking directly at the connector. You can see there are a lot of different layouts of how the inserts are arranged in the connector. But yeah, you kind of get the gist here of what an insert is in the connector. So like the connector body would be the whole thing, and then in these rectangular connectors you have like in this case 3 different inserts in the same connector. Okay, and then the contacts are the actual pins or sockets that go into the connector. So that's going to be the part that's carrying the signal through the connector that the wire is terminated with. And then the strain relief. Let's see if I can find a good picture of the strain relief here. So on the D sub connector here, as an example, this little piece would be considered the strain relief. So the cable is going to fit through the hole of the connector here, and then this piece is going to sort of secure the wiring at the exit of the back shell to prevent strain at the connector, like if there's any sort of movement at the connector back. Okay, and then we also talked about keying and locking and securing. So see if I can find a good picture. So these 2 circular connectors here at the top, you can see there's a little keyway right here, and then you can kind of see it as it goes around. You've got these looks like 1, 2, 3 more, and then one over here on the side, and then you can kind of see like what I'm not saying that these are connectors that mate together, but you can see there's sort of like an opposing keyway here that the mating connector would fit into. So examples of keyways And then as far as locking goes, this circular connector is a ratcheting style lock, and so if this connector were to mate to this one, you can see there's a little red line here that goes around the outside of it. So you would connect the connectors together and twist it, and you would hear like a ratcheting noise as it tightens down. And then once the connector shell, as it's tightened down, it's gonna cover up this red line to indicate that the connector is connected fully. So that's sort of like a visual indication of proper connection. And then right below it here, you can see these little bayonet pieces. And since this picture is black and white, these can be different colors, maybe blue or red. But after the connector is connected to its mate, you'll be able to see through this little sight hole here on the mate. You'll be able to see the color of that bayonet. So as long as it's in that sight window, you can be sure that the connector is locked. And then for the case of like D-sub connectors, we talked about there's a thumb screw on here, so like a screw and a nut sort of way to secure the connectors together, so those would get tightened down to each other. So so yeah, that's just like another method of securing the connectors once they're connected. Okay, and then some more about inserts. So like I said, looking at the insert of the connector itself, you can see there are these little numbers or letters that go around the insert, and these are just to identify where the wire is located within the connector. So that just it just helps to pin the connector out and just to make sure that you're getting like a one-to-one connection between the two connectors. And so like pin 1 is going to go to pin 1 on the opposite connector. So tons of different ways that these are laid out, but just wanted to put some examples up here so you can kind of see what's going on. So around the circle also, so it would be like 1, 2, 3, 4, 5, etc. And it kind of looks like a maze, but the numbers continue increasing until you get to like the very center of the connector. So lots of different ways that these can be laid out. But if you have to go through and like terminate a connector or remove and replace a pin inside of the connector, just wanted to be aware that this can be some common ways that the inserts are laid out. And then for rectangular connectors, it's going to be kind of like a similar thing. So looks like from here, from left to right, the numbers are increasing, and as you go down, they continue increasing. And you can see there are some different size contacts that are in the connector itself. So you could have like a bunch of signal wires within the connector, and then like a few larger pins that are for power and ground, or like even Ethernet or coax within the connectors. So just lots of different ways that these are laid out. And then my D-sub example here, you've got the number 1, and that carries over 1, 2, 3, 4, 5, increasing that way. So yeah, these are just some different examples of how the inserts are laid out. And then with the coax connector, you're not going to have numbering because it's just one connector. But one thing to note is that there's a pin, like a center conductor pin, and then the actual connector itself, like on the outside, is going to carry like shield ground through it. So just wanted to note that like there's no numerical pin out of the RF cable connector, but the outside body of the connector does carry the shield ground through it. Okay, so that's pretty much it for the different types of connectors. Trying to see if I had any last kinds of things here that I wanted to go over. Some more on inserts here. So like just kind of a few more notes. Like I mentioned that you can, in some of these terminal modules, you can have a diode. So like you can see the symbol for diode in here. Or if there's like a relay or resistor, you can see that there's like a little schematic printed on the terminal housing itself, or insert rather. And then you can see that some of these are divided just to kind of show that there will be continuity between some pins within the module, and there will not be continuity on other portions of it. So just kind of depends, and you just kind of have to read the note or like annotation on the module itself. And then I did want to touch on some different styles of coax connectors. So we mentioned bayonet style connections. So these ones up on top here are going to be bayonet style. So the B stands for bayonet, and it's escaping me what the NC stands for, but I think it's just N and C type connectors. So like there are different letters that denote the types of connectors that are out there, but yeah, BNC and C type are the two bayonet examples that I have up here for coax connectors. And then below it, these connector styles are going to be threaded locking. So SMA is going to be this one. SMC is going to be this next one over. TNC is going to be this one. So like the way that I've always remembered the TNC is the T stands for threaded, but that doesn't really make sense because we have SMA and SMC type connectors, but just because the TNC connectors are very common in aviation. So and then HN is going to be this connector over here on the right side, which is just like a larger coax connector. So so yeah, just some different flavors of coax connectors here that are pretty common in aviation. All right, and then let's see what else I have lined up here. And then just to kind of see how a coax connector is terminated, I just wanted to put an example installation or assembly instruction up here. But you can see if you watch the previous video where it has like a view of how a coax cable is laid out. This just kind of breaks it down. But you can see there's a shielding and the center conductor, and you're going to be like folding the shielding back, and then you can see there's like the insulation that goes in between the center conductor and the shielding that goes around the outside. And then there's going to be like a ferrule that goes on before any of the rest of the connector goes on. So like this little rectangle here is called a ferrule, and that is going to basically like bond the braiding to the connector itself. So so it has you put the contact on and crimp it. This is the contact here. and then you press the connector onto it, and then slide the ferrule up onto the connector itself. So you fold the braiding back onto the connector, and then you're going to crimp the ferrule down around the connector itself. So just this is kind of a snapshot of how a coax connector is going to get terminated. Okay, and then we also talked about the polarizing keyways, or sort of alignment ways that the connectors are engineered so that they'll mate together, and can sometimes prevent confusion of like connecting the wrong connectors together inside the aircraft. And then we talked about the different types of locking and securing mechanisms. Some connectors can also be torqued, so like our SMA connector here, for example. So connectors that are threaded, there can sometimes be a torque associated with those, so that you're not over or under tightening those. And then some connectors actually have safety wire holes in them, so that they can be secured to like the airframe, or the adjacent connectors, or something along those lines. Okay, so next section here, splices, terminals, and contacts. First, I wanted to talk about contacts and how they're identified and some common types. So the two different types of contacts you're going to see are pin or socket. And so the pin is going to be these guys down here. And pin, like you could think of as the male side. Socket you could think of as the female side. So these are going to be sockets. And then it's pretty common to see sealing plugs as well. So so if we look back at our inserts here, so if you go through and terminate a connector and not all of the spots get used for the termination, you basically have empty spots, and these sealing plugs are going to prevent like dirt or debris from getting into the connector, and just kind of helps protect it. And then some pins are crimped, some pins are soldered. I would say more often than not you're going to be dealing with a crimped pin, which uses a tool with a die to crimp the pin around a wire when you terminate it. So this top left one here is a Molex pin, and you can kind of see how there's kind of like two sets of wings that crimp around both the conductors and then the jacketing or insulation that goes around the outside of the cable. And then these color bands are used extremely frequently to kind of denote the part number of the pin, or contact rather. And it's just like a 3-color band scheme. And we can talk a little bit more about that, but this just kind of helps you identify the part number of the contact itself, and then what tool you can use to crimp the pin on the wiring that you're working with. So you can see over here these pins have 3 different colors on them, and these sockets have three different colors on them. So different color combinations to sort of denote the part number and what the tooling is that you're going to be using. So and then more about the way that the pins are manufactured. there's a little sight hole or witness hole here on the termination end of the contact. So that's just used to show that the length of wiring that you have stripped is long enough to fit into the pin or the contact rather. So when you crimp the area behind it, it's just to make sure that you have enough wire in the barrel of the contact, so that you're getting a good connection. So and then this is going to be the mating end of the contact. So if we were to look at this, not sure if I can really, I can't really see the sight hole on these on any of these pins, but you can see this little part here is in between the wire barrel and the mating end, and then this is the actual contact pin or socket side of the contact. And then some more about tooling. I have another video lined up here that will get more into the tooling that you use when you go through and actually terminate the contacts. But if you look in the description below, I put a handful of different videos that show different tools that are used commonly, if you want to check those out for this video. But just some stuff from, I think it was DMC tools, but check those out. Lots of good videos in there to see physically like how the tools get used to terminate the contacts. All right, and then for contact installation and removal into the actual insert of the connector, there are tons and tons of different types of insertion and removal tools that are used for connectors. So just have a handful of screenshots up here of what they might look like. So so these ones are just like a plastic end, and then these ones are metal. So like the plastic ones would be used for like a silicone insert. What's up?
Are you got plans for Friday night?
Yeah.
What are you doing?
Hanging out with Matt.
Our Matt? Okay.
Yep.
When you get a chance, I think I'll wait run downstairs.
Okay.
You gonna wait up for Mariah?
Probably not.
Okay, good night.
Okay, good night. So anyway, yeah, plastic insertion removal tools for inserts that have like a silicone or like weatherized substance in them, and then we've got some metal ones over here that are used for like a hard insert, which is probably going to be more common with like those rectangular connectors that we were looking at, or like D-sub connectors. And then some of the pins can be front release, so there's like a little spring actuated removal tool here that fits over the contact, and then there's like a little plunger that pushes the pin out. So yeah, lots of different flavors of installation and removal tools, and the different colors here for these top examples is going to sort of denote the contact gauge that the tool is used for. And then one last important note too about installing connectors, installing the contacts into the connectors, is that you can do a tug test. So you would insert the contact into the connector itself, and then you would just pull a tiny bit to make sure that the contact is seated into the connector itself. Okay. All right, so a bit about splices here. These are really commonly used splices. So they're basically just butt splices, but also called an environmental splice because there's a little plastic sleeve that goes over them that gets shrunken down like with a heat gun or heat source, and then you can see there's like a little glue that gets squeezed out the ends here to just to remove the metal and the wiring from the elements. And then this one down here on the right is just there's like a little connector insert in there, and so you would put pins on the two ends of the wires, and those would just connect inside of this little junction splice. But kind of how these work in a nutshell is you would strip the ends of the wires and insert them in the barrel of the splice, and you've got another like sight hole window here so that you can make sure you've got enough wire into the splice. And then you would crimp, you would use a tool to crimp the splice kind of like in this area, and then you would slide this this heat shrinkable tube over the outside of it and shrink it down. So depending on the wire size, you can fit several wires in the barrel or just one wire. So there are different capacities that these splices are rated at. And these are mainly used for terminations or for making wire repairs. So like if you found a damaged wire and you had to cut it and splice it back together with the wire, this would be kind of like a way to repair damaged wiring. All right, so onto terminals. These are some examples of ring terminals that are used in aviation. So some of them can be insulated. Some of them are not insulated, so you might have to put like a little heat shrinkable tube over the end of it to cover up the termination. But different colors denote the different gauge of the terminal itself. But yeah, here it just kind of looks like if you've ever worked on like on a car or something, it looks like a ring terminal that would go on a car battery or something like that. But yeah, you'd strip the wire back and insert it into the barrel here, and then use a tool to crimp it down, and then a portion of the wiring gets crimped around the metal part of the terminal, and then another portion is just floating into the insulation of the ring terminal here. But so common applications for terminals could be power, which would usually be at a circuit breaker, but there are cases where it could also be used for components. So for like relays or solenoids, that sort of thing, like in starting circuits, and then also for grounding and bonding, and then also for junctions. So if you're connecting a lot of wires together, there can be cases where you have a junction set up for your wiring. All right, and then I wanted to throw up an example here of a circuit breaker panel. So this is the back of a circuit breaker panel, and you can see all these wires are bundled together and terminated with ring terminals here. And so you can see if I can maybe zoom in, maybe not. But yeah, they connect to the back of the circuit breaker, and you can see them all sort of lined up here. So there's this section connects the ring terminal to the circuit breaker, and then on the other side, this is the bus bar. So it's just like a copper bar that goes along the length of the circuit breaker row, and so these are just like on the common bus, and then the load wires go out to the different components that the breakers are connected to, and then you've got looks like some switching in here, and like some other types of terminals here, maybe like fork or like bayonet kind of terminals. And then this picture down here, I pulled this from the AC 4313, and this is just sort of like a standard way that you would install a stud to the airframe and use this for grounding. So you can see there's a stud that you would secure to the airframe with a washer, like a lock washer and a plain nut, and then you would put the terminals on top of the washer, and then use a lock nut to go over the terminals themselves to lock it onto the terminal itself, or stud, I should say, onto the stud. But this is just kind of shows you the stack up of the hardware and how that would be arranged. Okay, so just to wrap everything up here, connectors, most common types are going to be circular, rectangular, D-sub, coax, junctions, and terminals. Make sure that when you're connecting them up, you want to make sure that you use the applicable locking technique per the manufacturer specs. So whether that's like a ratcheting or bayonet type, or like a screw type, just making sure that if there's like a witness marking on the connector, you want to make sure that that's covered up so that everything is secured. We talked about the red band that goes around the circular connectors, or like coloring that would be on the bayonet studs of a connector as a way to see whether it's secured. Contacts, those can be a socket or a pin, and commonly use color bands to identify the part number of the contact itself, and which tooling you can use to crimp those pins and work on the contacts. For installation and removal of contacts, you want to make sure that you use the proper tool that's called out by the manufacturer, and that can be front release or rear release, and you can have plastic tools or metal tools depending on the type of connector. So just make sure that you're following the manufacturer instructions for removal and installation. And you always want to make sure that the contact is locked into the connector, so there are little locking mechanisms in the insert of the connector. So if you're ever installing a contact into the connector, you want to do a little tug test just to make sure that it's secured into the connector. For splices, you want to make sure you follow any wire sizing guidance. So there's usually a chart for the different types of splices, the size of the splice, and the like the maximum American wire gauge, AWG, that will fit this in the splice barrel. So you just want to make sure that you're following the instructions for those. And then last but not least, I do have a bunch of clips, YouTube clips, for how some of these the different practices for using these components. So like terminations, crimping the contacts, crimping the terminals. I've got a bunch of links for videos in the description of this video below. All right, so just wanted to open it up here for questions or comments. I'll check back here to see if anybody joined up and anybody put some comments in. And then last but not least, I also have an A&P Quick Start Guide PDF. Link is in the description below. That's markhjoy.com/quickstart. And that's a guide for anyone who's interested in getting their A&P, but they're not really sure how the whole FAA process works. It kind of walks you through from start to finish all the different boxes that you need to tick in order to get your A&P. So good for people who have really no familiarity with the process of getting your A&P, or for people who might be in the military and want to get to the civilian side of aircraft maintenance, or even for people who are working in the industry right now but don't have their A&P and are interested in getting their A&P. So go ahead and download that for free. Just a little gift for saying thanks for stopping by for this presentation. And I'll just hit the escape key and check to see if anything came through in the chat. Looks like their chat's empty, so that's all good. But yeah, I'll just give another couple seconds here because it looks like there are three people on right now. But even if you want to say where you're from, anything, it doesn't matter. You don't have to. It's okay. But yeah, that's all for now. Thanks everyone for stopping by. And if you watch this after the fact, please leave a comment below with any questions. Apologize for my voice being hoarse. Like I said, I'm getting over COVID-19, so just not feeling 100% quite yet, but yeah, doing all right now. All right, Captain 4X, I see you typing things. You're from Brazil. You moved to the U.S. Congrats, that's awesome. Yeah, my pleasure helping out here. It's not a problem at all, so that's what I'm here for. Any questions, Captain 4X, or are you good? I think there's also a massive delay. Okay, taking your general test now. That's awesome. Best of luck to you. How can you study for it better? Okay. So biggest thing I can say is go and buy study guides for it. And how can I improve my understanding for the process? So yeah, I would say if you haven't already purchased the study guide, so ASA is the company that I used for my study guides, and you can get study guides for the general and airframe and power plant, and how can I improve my understanding for the process? I would also recommend, if you can, find a DME, or maybe even the DME that you're going to be taking your test with, to kind of like talk about kind of what to expect, and that can also sort of help you get to know a DME, which is the person that's going to be administering the oral and practical. But if you're talking about the written tests, you can also take practice tests. The website is escaping my brain right now, but there is oh man, I should have this bookmarked also. But you can actually get on the internet and take free practice tests that are based on the study guides for general and airframe and power plant for the writtens. I can look that up and post it in the video comments as well. And I'm trying to remember, for some reason it's escaping me, but I think it's on the FAA website as well, if you do want to look it up. Yeah, free practice. Yep. Another thing you could do also is for the written tests, there you can also find like audio books, or like not audio books, but like an audio recording of someone who went through and like recorded the study guide, so you can like listen to it in your car, or like put in your headphones and listen to it. So that's another helpful thing you can do if you don't have time to read, or like just want to digest through listening. Like if you do better, just kind of like listening through to it. And I know that there are other YouTube channels where people like they just did videos where they just read the actual study guides. So you can search YouTube for those. I've been thinking about making some of those myself, just for people to grab. But yeah, that can be another thing that you can use for studying. But yeah, the free tests, like you can take those as many times as you want. I would say that's probably like as close as you can get to taking practice tests. And yeah, any other questions? Thank you. I try. It's just been I'm like relearning a lot of these the A&P sort of like knowledge things, like for these presentations too, going through for basing my content on the ACS, the Aircrew Certification Standards, just because like it's even changed since I took my tests back in 2000, beginning of 2008. So like it's just kind of like a good refresher for me to go through all this stuff and try to help people out. But yeah, glad this is helpful for you. Even though we just have a couple people on here, hopefully a good amount of people checking this out after the fact. So cool. So I guess just like one more opportunity for anyone to ask a question. Looks like we just have 3 people on here, but thanks everyone for jumping on here, and I'll just give a couple seconds for the delay if anybody else has a question. All right, cool. Yeah, anyway, as always, anyone checking this out after the fact, feel free to shoot me an email to mark@markhjoy.com. Put a comment down below and I'll try to get to it as soon as I can. As always, I don't know everything, but I probably can find someone who does, or find a way to find the answer for you if I don't know it off the top of my head. But anyway, thanks everyone for checking this out. We'll see you in the next one.